Hi, so today we're going to present a project that we did last year for the Government of Alberta. And the title of the presentation is How to Develop Automated and Streamlined Data Processes for FME Server. My name is Leslie McKenzie, and I'll be doing the presentation today. So who we are, ConcertTech is a SAFE software partner. We've been partners with SAFE for almost 20 years. We are a team of experts in developing on FME server, and in training and coaching. So in this presentation, we're going to learn how FME was leveraged to develop automated and streamlined data submission processes at the Forestry Division of the Government of Alberta. So the objective for this project was to develop a way to collect forest activity information from forestry companies and be able to have a streamlined way to accept the data, review it, process it, basically create a portal, an exchange space between the data submitters or the data providers, which are the forestry companies, and the Government of Alberta staff who need to validate, accumulate, and publish out this information. So the presentation is broken into several topics. So we'll start with an introduction, the business context, so why the project, how it came about, what kind of information is important to them, what is FME, and why was FME chosen for the solution, an overview of the technical solution that got implemented, and some lessons learned and conclusions. So the business context. So the name of the project was the Spatial Data Directives portal, and there were two main drivers for this project. One was the Auditor General. They need to know, that specific forestry activities have occurred, so harvest areas, silvicultural activities, where they occurred and when they occurred. They need this information for provincial and regional level analysis, management, approval of activities, planning. So this information that needed to be collected is used at different levels of government. It's used by different types of professionals. It's used across the organization in order to, for sustainability purposes, for, accountability, and different reasons. So so what they specifically needed were standardized data sets of information coming in, because they were getting information in all kinds of different ways, and what they wanted is a streamlined way, a streamlined data standard to submit this information, and a way to automatically provide feedback as well. So these standardized data sets, they were going to be used for, as I mentioned already, basically reporting, compliance and enforcement, and planning. So the kinds of information that this first phase of this project wanted to collect. So the idea being that there's several types of information that data providers have to submit, but the portal itself was designed to start with specifically the harvest areas and the silvicultural activities areas. So the harvest areas, the boundary becomes a permanent record, and then it's used for subsequent planning activities and forest inventory and different projects like that. They have to submit also the as-built roads, as well as watercourse crossings. Silvicultural activities is the other set of data that is uploaded to this portal. So these are spatially explicit silvicultural activities. So this can be like different treatments on forest, herbicide applications, and different kinds of activities that we see. So the benefits to the department, so the benefits to the Forestry Division were going to be efficient validation of key data sets. So they want to be able to streamline the receiving of this data from these different companies, being able to, and with good data that would allow them to do monitoring, analysis, reporting, planning, and different kinds of compliance activities. And the benefits to the data providers of streamlining this process was by having a standardized way to submit the data, we kind of level the playing field, in the industry. The contractors and consultants will know exactly what is expected, so more clarity on the expectations, And part of this was to be able to provide quicker feedback back to the acceptance of this information, and also provide templates and so, as a guide for the information that needs to be submitted. So the project was started a number of years ago, and a first version of submission standards were put out and through several iterations. And they wanted to put out basically a new version, but with a tool, which is where we came in. So the issues in general with the data being submitted was that the data was falling below the expectations for quality. There were numerous resubmissions. There was no clear process. There was no consequences or accountability for submitting bad data either. And this created a lot of internal work among staff in order to produce data that could actually be utilized for purposes such as analysis and planning. Other issues included, the time to convert the data, as I mentioned. The naming system was not reflecting the current content of the data. So they reworked the data standard and also wanted to find a new solution for submitting this data. So the Forestry Division looked around for some solutions. They found that FME had been used by other upload and submission portal type of data processes in order to streamline the receiving of the data and some of the auditing that could be automated. So they decided to use FME as the basis for this automatic validation and submission data. So the advantages to using this were by having some of the validation steps automated, this would reduce turnaround time for evaluating and publishing the data because we reduce the amount of manual validating that needs to be done, and ensure that the data gets to the staff more quickly so that the data could be used more quickly among the rest of the staff. So they did a study and put together the components for the new system. So there's 4 main pieces. So one, divided into 2 sides. So one is the web portal, and the other main side is the validation and approval process. So the web portal is the development of a web interface with login requirements, with account management that would allow data providers to make their submissions and also receive feedback on it. So, by receiving, output data packages, reports, and different information. And so this is the interface, between the government forestry division and the data providers. And then the validation and approval, the backend processes, has 2 main components. So the one that we developed would be the automated QA/QC process using FME and FME server technology. So that would be all the things that could be validated automatically without human intervention. And then there's an audit process. So there are internal auditors that do the rest of the validation of the data. So just a quick, what is FME? FME is a data integration solution. It's an application that lets us pull data from many different data sources. And so here we see some examples such as Esri and SAP. It doesn't all have to be spatial, but FME comes from a strong spatial background. And so there's a lot of spatial capabilities built in. And the idea is to be able to provide data as needed in the form needed to different departments or different systems automatically. FME comes in 3 different main applications. So we have the desktop application. So this is where we develop our data processes, so automated data processes. And then we use the FME server or the FME cloud in order to automate those data processes. So how those processes get, triggered and run and notified on. So FME desktop in action. So this is just a quick example to show what does FME desktop look like. What does one of these data processes look like really quickly? I can see I have data that comes in on the left side, and then I have a chain, a workflow built with arrows and boxes the boxes The blue boxes are called transformers, and they manipulate the data. And then once I get to the end, I write data into my output data set. So with FME, that server, that allows us to either self-serve or schedule or have event-driven tasks. So if we, in the case of this particular project, we utilize the REST services in order to automatically trigger data processes to run. So an overview of the technical solution of the Spatial Data Directives portal. I'll start with the design. So there were some design considerations here. When we started working on the project, there was a proposed design. We made a few changes to it. We wanted to think about the bigger picture a little bit, make sure that the solution on the FME side was scalable. So what does that mean? Well, today we're validating just the silvicultural activities and the harvest areas, but there are other data sets that need to be, submitted, and maybe even outside of the scope of this particular group. So the idea being that if we went with a modular design and that was scalable, we would be able to add more modules on later. So we broke the validation requirements into separate components in order to make it so that pieces could be interchanged with time. Maybe new validations will come in and they can be grafted onto the process. Or perhaps some changes to the data structure would be required. For instance, new fields, changing the names of layers, or new attribute requirements in the data validation tools. And we want it to be flexible enough that we can change this change some things without it being fundamental to the application, so that the application can evolve as the data standard evolves, as the validation rules evolve, as maybe what the process is applied to evolves. And the other thing we considered is also the reporting. So there are two main reporting mechanisms in a data upload, submission, and validation process. So there's the reports that come from validating the data itself. So we did the automatic validation, and this is what we found in the data. But there's also, how did my process go? Did my process function correctly? So this allows me to have some traceability on the functioning of my portal itself. So we want to build different kinds of reporting, and then we want those reports to be catered to the different audiences that they're for. So the backend data process itself, as I mentioned, was done with a modular approach. So what does that mean? Well, this is a conceptual idea of how this works. So the user here on the left has uploaded a submission. Okay, so this would be like a zip file containing the data that's being submitted. And a REST call is then made from that web portal to the FME server. An FME server receives the request and then runs a parent process. And so a parent process is a data process that's being used to kind of orchestrate all the steps of validation in this case. So we have sub-processes to do the validation of the schema, validation of the attributes, and the spatial validation. By separating those main pieces out, I'm able to add some more, change some. If I want to change something in how I validate the schema, it won't have an impact necessarily on how I do the spatial validation. So this allows me to test parts and pieces separately and adapt them separately as well. So we also went with a validation rules lookup. So the idea being that if some simple rules change, like which fields or attributes are allowed to have null values, we can just change the driving configuration file instead of having to actually change the underlying code. Because we all know that we work hard to develop a standard, and we'd like to say that the standard is like this way and will remain that way forever. But in real life, this is not what happens. And at the output here, I have a number of reports. So I have some text files from GIS data. We have some notifications sent via emails that all get produced from this process. So the main three things we're validating are the schema. So these are the names of the tables, the attribute types, the domains, the attributes themselves, so the values and the attributes. Do they follow the value ranges? Do they follow acceptable values if there's a domain? Are null values allowed? And then spatial. So for the spatial, the checks were, overlaps, duplicate features, areas being larger, like within the acceptable tolerance, and features like that. So this is an example of what that configuration file looks like. In the rules tab, you can see here that we have a list of attributes and we have a column that says null. So which ones are allowed to be null and which ones are not allowed to be null. So if it's an N, it means that column is not allowed to have a null value. So if those requirements slightly change, we can just change the lookup. And this is a strategy we use in a lot of these types of submission portals because we know that there is often small changes to the standard. And so this allows for us to just change the standard, upload a new configuration standard, and then work from there. This is an example of what the master process looks like. So the master FME process is the one in this case that's kind of doing the orchestration. So it's the one that receives the REST call. So the REST call initiates this FME process. And then at the beginning here, we're initializing some reports. We're doing the schema validation, we're doing the attribute validation, we're doing the spatial validation, and then we have some reporting built in. And at the very end, we update the portal with the status saying that it's past this automated QA, and now it's going to go into a manual audit, for instance. In the reporting, as you can see, there are some branched reporting. So there's some reporting that's to produce the actual results of the data. So that's this reporting over here. But then there's some other reports that are more tracking the process, ensure that all the steps ran correctly. This is what one of those sub-processes looks like. This is the attribute validation process. So just to give an idea of how, we break this down into simpler, easier pieces to manage and kind of assemble together. So I'll just give a quick show of what this looks like here. This is the parent process. So I have some green tools here. They're custom transformers. These are small sub processes. I have some reporting. Here I'm running a sub process and I'm waiting for it to complete so that I can report out on the success. I look at the attribute validation tool. I bring my data in here, and here I'm checking my data against the rules. So I'm reading the rules in from my Excel spreadsheet. I'm reading my input data, and I'm validating my input data against each of those rules. So what do we output from these data processes? So some reports, like I said, are more about the process management. So I can see here in my output package that I have some temporary data, I have some logs, I have some, text files that say that, what got executed, that the status of, the execution is successful, and some information like that. So this is not for the end users, for the data providers. This is for the administrators of this portal to make sure that they have a traceability, that things worked correctly. And so they have a place to go and look if something went wrong in the process. Maybe some data got uploaded that was corrupt. And so the data process got halted along the way, for instance. So this will give them some feedback as to, where the data got to and where things might have gotten wrong. The reports that we send back to the data providers, this is an example of the GIS report. This gives an actual spatial object showing the types of errors. So there's a layer for overlapping objects. There's a layer for duplicate, treatment areas. There are, different layers showing the different kinds of areas that got tested. And here's a small HTML report that shows, in this case, the process that got that failed the submission, how many features got processed, how many errors were found, and then a summary of the errors that were found. So we often like to build the very detailed report that they all need to actually correct their GIS data. We often like to also provide like a summary to show, okay, high level, so that you can have kind of an approach of how to, approach the corrections. On the portal side, now that's the back-end data process. So now on the side of the portal itself, the web portal, this is an example of what the submission process looks like. So the user logs in. Are they registered? No, they have to request an account. If they're registered, they can have access to a number of activities. And those activities include being able to download templates, upload data, review the status of their submissions, and access different documentation. The process designed by role. So the portal itself has 4 main different roles. So there is the template administrator, so that, template for the driving the data validations and, different kinds of kinds of parts of the portal. We have the data provider, so that's the main external, forestry companies and such that are actually submitting their data. So these are the processes and how they interact with the site. So it's uploading data, it's getting some email notifications from the system to say that things were accepted or rejected. There's the administrator. So the administrator is the one who determines who has access to the site and can, ensure the functioning of the system. And then the auditor. So the auditor is internal staff of the forestry division, and they will do the manual audits, the business audits on the data. So once the data has gone through the automated data validation, it goes to an auditor. So there's 4 main roles in this portal. So these are just examples of what the pages look like. So the login page. And once a data provider, this is from the data provider's point of view, once the data provider logs in, so they have their 4 activities that they can do. So uploading, reviewing, getting access to documentation and templates. When they go to actually submit a file, they have to provide a certain amount of information, and then they can choose a file and they submit their package for audit. And then when they want to see the results, they can go to this page and it will give them access to view their reports and to see what's, what the status is of their audit, because obviously there's, like I said, the, automated audits and the manual audits. So what were the challenges and the conclusions of this project so far? The advantages, higher productivity for both the government and the industry staff. So there's a clear way there's a clear way to submit this data. The standards are clearly identified, and feedback. There's a way to provide, streamlined feedback, process. So good communication. Some of the challenges, implementation into production has been delayed because of the election and internal staff issues. So a little bit of, things that had to be worked out and ironed out. So they still need to conduct an external stakeholder consultation because they weren't able to get into production for this year because of the various challenges. So they are targeting March 2020 for implementation with external stakeholders. Lessons learned. One is ensure that you have well-defined business rules that will translate to automated validation. I do have to say this project was won through an RFP, and in the RFP there was very clear and distinct documentation. They really had a technical requirements well laid out in terms of what the validation test cases needed to be. And this allowed us to see the logical groupings. Okay, there was attribution, spatial, and to see how we could architect the solution. Another lesson learned, think of the big picture. It's not just one data set. but an architecture that could be extended. So in early conversations, we saw that, yes, these are the requirements for this project, but the idea is they're building something they want to be able to build upon. So we considered that in our design, and we worked with them to make some adjustments to the original design in order to give them that future flexibility and ease of use. Make the design modular. So the idea of being able to break apart the data process. Good test data that will validate your implementation. They had very good test data and test cases. This is critical because anytime we make changes to the process, so having good test data is more than just getting that first round into production. Having good test data helps us be able to make changes in the future to the system and be able to quickly test and turn around changes, adjustments, improvements, into production. So this becomes our, baseline for how the product, what is supposed to happen when we run the product. So good test data makes a big difference. So what are the next steps? Get the project into production, increase its visibility, and then, work on expansion to other data sets. So thank you very much. If you have any questions, please feel free to contact us here at ConcertTech or myself. My information is here in front of you. Thank you.